step, application of the little cushioned protective pads. The material used for the pads are shown here as a large roll of fabric which will have to be cut. Here a machine cuts the fabric pads. These extremely sharp blades have to be sharpened every 6 months. The cushion fabric is separated into narrow strips which will later be glued to the ETS fabric. The strips of cushion fabric are now ready to be applied to the bandages. This is the machine that fabricates the bandages. The roll of bandage components is unrolled. The machine assembles them, then cuts and individually wraps them. The bandages are wrapped one by one. This machine applies the unprinted white wrapping paper which protects the bandages. And now they proceed to packaging. Packaging speed depends on the product, varying between 300 and 1,500 bandages a minute. This roller perforates holes which will allow the bandages to be easily separated from one another. Strips of bandages are then placed into boxes. Here we see other small bandages which are made in a different way. The cushion strip is positioned at the center of the ETS fabric strip. The cushioned pad isn't sterile at this stage. They will have to be sterilized right at the end of the fabrication process. Next step, applying 2 plastic paper protectors over the glue-covered ends of the bandage. This done, the bandage is drawn by suction with a robotic arm and placed between 2 wrapping papers. In slow motion, we see the wrapping action better. This machine is much faster than the eye. At full speed, it can wrap 300 bandages a minute. The bandages exit the machine perfectly wrapped. Certain types of bandages have to go through a sequential bandage machine to have aeration holes pierced in them. These holes allow air to circulate and thus help promote healing. These bandages are now ready. Sometimes they print instructions on bandage wrappers. This paper printing machine is used with bandage machines. 2 polymer plates receive ink from a series of rollers in order to reproduce the desired design. The bandages pass through at high speed. Before being packaged, the bandages are finally sterilized 10,000 at a time. Bandages are automatically counted here, placed in a chute, and fall into the packaging box. The large roll of ETS fabric seen at the beginning will have allowed them to make nearly 2 million bandages. Each year, this facility produces a staggering 4 billion bandages in 65 different models. Electronic circuits once involved miles of bulky wiring. Today, they're reduced to compact units, like this computer circuit board. If there's a problem, simply pop in a new one, and you're back in business. An electronic circuit board is a computer component which can produce spectacularly realistic scenes. Animating this particular 3-dimensional graphic took 4 months of work by artists and programmers with the aid of a G400 graphic processor by Matrox. A printed circuit board can be compared to a building composed of fiberglass floors, copper passageways, and stairs that link the floors between them. Cards are assembled with 2 technologies, surface wiring and wiring through the card. The components are placed into the holes and soldered into place. A stencil is used to apply soldering paste onto the card. This paste will solder the surface components. Here they place the stencil into the printing unit. It is through these holes that the soldering paste will run. The machine spreads the soldering paste, which contains, among other elements, a tin lead alloy. The printing blades go into action. They spread the soldering paste on the stencil. This paste runs through the stencil holes and covers the metallic surfaces of the printed circuit board, which will establish the electric current. Here's the difference between an unprinted card and another printed one. The unprinted card surface is much more shiny. Now they're going to install the surface wiring elements. They are automatically positioned by this rapid placement machine. About 36,000 components are installed per hour, making it about 10 a second. This incredibly sophisticated machine is equipped with a viewing camera which verifies the alignment and dimensions of each part before installation. It unerringly positions the part at the exact spot. Another machine, slightly less precise than the previous one, installs parts where the space between two placement points is less than 0.5 millimeters. It can install 8,000 parts in 60 minutes. The card continues on its way toward the oven, which accomplishes an essential operation. Once the parts are secured, the card goes into a convection oven where the heat will solder the parts to the card. Different circuit connectors through the card are inserted into their respective holes. This operation requires great dexterity and is entirely done by hand. Then the metallic placement points need to be soldered to this card. The soldering of the circuit components through the card is done with a bath of molten tin lead alloy at a temperature of 240 degrees centigrade. Now everything is installed.